Let's talk about the acidity of oxides. As we can see with the trend, the acidity of the oxides of it increases across a period. Here we got the third period from sodium to chlorine, and their oxides are here. And what happens is that the acidity increases across the period for the oxides. And here what we have over here is the different oxidation states for these oxides. Here we have phosphorus. We have a phosphorus 3 oxide and we have phosphoric 5 oxide. Here we have sulfur dioxide, sulfur trioxide, and basically the oxidation state becomes higher towards this direction. And when the oxidation state of the element in the oxide increases, the acidity increases also. That's the trend, and we will demonstrate it in this group also. This is for what happens in period 3. This is what happens in period 2. It's the same trend across the period. The acidity of the oxide increases, while when increasing the oxidation state of the oxide also increases the acidity. As we can see, sodium oxide is a strong base, magnesium oxide is a weak base, aluminium oxide is amphoteric because it acts both as a weak base and a weak acid. Silicon dioxide acts as a very weak acid. Phosphoric 3 oxide acts as a very weak base, while phosphoric 5 oxide acts as a weak acid, very weak acid, weak acid. Sulfur dioxide acts as a weak acid, while sulfur trioxide acts as a strong acid. Chlorine 2 acid acts chlorine 1 acid acts as a hypochlorous acid. It's actually called hypochlorous acid, acts as a weak acid, while hyperchloric acid acts as a very strong acid. While over here, lithium oxide acts as a base, beryllium oxide is amphoteric, and so is boron oxide. Carbon monoxide is neutral, while carbon dioxide is a weak acid. Now here we have all the oxides of nitrogen in increasing order of oxidation state. Here we have nitric 1 oxide, which is neutral, nitrous oxide, nitric 2 oxide, which is neutral. We have nitrogen dioxide, which is a weak acid. We have nitrogen 3 oxide, which is acidic, and nitrogen 5 oxide, which is a strong acid. And we have F2O, which is neutral, surprisingly. So basically what happens is, you see metal oxides, they react with water to form their metal hydroxide, and the metal hydroxide, it dissociates to form the metal cation and hydroxide ion. While if it's a non-metal, the non-metal oxide reacts with water to form the non-metal acid, and the non-metal acid, it dissolutes to form the non-metal anion and hydrogen ion. So this is why the metals, they tend to be very basic, while the non-metal oxides, they tend to be acidic. You see, increasing the number of oxygen has a tendency to increase the oxidation number, and keep in mind that increasing the oxidation number has an effect of increasing the acidity. Now down the group, as we can see in the same group, nitrogen, phosphorus and arsenic, the acidity decreases down the group. That is a trend that has to be noted.